All right, hello and welcome to the AI Research Roundup. I'm your host, Alex. Today is May 4th, 2025. We're diving into this ICLR conference paper called Decoupled, Embeddings for Pre-Training Language Models, published just over 3 months back on January 22nd. So this paper addresses challenges when training large models on mixed data sources, like different domains or languages. Their core idea involves decoupling token embeddings from the main transformer body during pre-training. Okay, so this first figure lays out the different training pipelines. On the top left, you see the standard approach, where everything's trained together. Then, it shows the 3 department variants: trim, glob, and spec. The core difference is how they handle the embedding layer versus the main transformer body. See how in spec, the embeddings are fully separate for each data source, while only the transformer body updates are aggregated centrally? This visualizes that decoupling idea. Building on that idea, this algorithm here formalizes the decoupled training process. You can see how for each data source, it performs local updates in parallel. Then, crucially, it computes parameter updates separately for the transformer body and the embeddings. Notice how the transformer body updates are always aggregated, but the embedding updates are handled differently for glob, trim, and spec, really showing that decoupling mechanism in action during the optimization steps. Following that algorithm, this table really drives home the efficiency point. It breaks down the theoretical memory and communication costs for each method. You can see how the department variants, especially trim and spec, significantly reduce the per-step communication overhead compared to standard training, thanks to that decoupling. Spec also shows reduced memory cost and, importantly, enables vocabulary-agnostic training, which is a neat outcome of the fully decoupled embeddings. Okay, so building on those theoretical savings, this table gives us the practical memory and communication costs observed. Take a look at the per-step comms cost column. Wow! Compared to standard training, the department methods, particularly spec and spec opt, cut communication down drastically. We're talking factors like 0.0006x or 0.001x. Memory usage MK is also reduced, especially for spec opt. This really shows the tangible efficiency benefits of decoupling in action. Okay, so those tables showed the efficiency benefits. Now, this figure highlights another key advantage: robustness. It plots the activation norms and model parameter norms during pre-training on the PILE dataset. Look how the standard training methods, STD, eventually diverge. Their norms just shoot up, but the department method stays stable and low throughout. This really demonstrates how decoupling helps resist the negative interference and divergence issues when training on diverse data. So, after seeing that stability, this table here shifts focus to generalization performance, measured by perplexity on the MC4 dataset. Lower is better here. It compares the department methods, glob, trim, and spec, against standard training and ACT baselines across various languages, both in distribution and out of distribution. Well, look at those average scores. Department clearly achieves lower perplexity, meaning better generalization, often by quite a margin, especially on the OOD data. Alright, and similar to the MC4 results, this table shows validation perplexity, but this time on the PILE dataset after continued pre-training. Again, lower is better. Across the board, the department methods achieve lower perplexity compared to the standard training baselines, showing an average improvement of about 15%. Spec opt, with its optimized vocabulary, does particularly well on certain sources. So this further confirms that department improves generalization on diverse datasets. So wrapping things up, we've seen department consistently achieve better generalization, shown by that lower perplexity across different datasets. And perhaps even more striking are the huge reductions in communication and memory costs we saw in those tables. This decoupling approach really seems effective for training robustly on messy, heterogeneous data mixtures. Well, that's all for this week's AI Research Roundup. Thanks for tuning in. I'm Alex.